46,000 electrical fires every year in the United States. And investigators say a large percentage trace back to one thing: a code violation that should have been caught. In this video, 10 NEC mistakes that fail inspections constantly, and several that show up on the Florida EC licensing exam. Starting with one of the most common violations inspectors see in the field. Overfilled conduit traps heat and destroys insulation. The NEC controls this in Chapter 9, Table 1. The fill limits are 1 conductor, 53%, 2 conductors, 31%, over 2 conductors, 40%. Calculate fill before you pull wire. Inspectors catch this one by looking at conduit entries. If it looks crowded, they measure it. Exam tip: the 53-31-40 rule from Chapter 9 is a tested concept on the Florida EC exam under the raceway and enclosure fill domain. THHN is rated at 90 degrees Celsius. That does not mean you size it from the 90-degree column. NEC 110.14C is the rule. There are two paths: for equipment rated 100 amps or less, or conductors 14 AWG through 1 AWG, use the 60-degree column. For equipment rated over 100 amps, or conductors larger than 1 AWG, use the 75-degree column. Both paths have the same exception. If the equipment is specifically listed and labeled for a higher temperature rating, you can use that rating instead. Always check the terminal label before you size the wire. The 90-degree rating is used for derating calculations only. Exam tip: the 60-degree termination rule is one of the most tested ampacity concepts on the Florida EC exam under the conductor sizing domain. Quick question before we keep going. Which NEC table sizes equipment grounding conductors? Table 250.122. Keep that one in your pocket. It comes up in the field and on the exam. An undersized equipment grounding conductor cannot clear a fault fast enough. The breaker may not trip, and metal equipment stays energized. Size it using NEC Table 250.122. One rule many electricians miss. NEC 250.122b says if you upsize circuit conductors for voltage drop, the equipment grounding conductor must be proportionally increased as well. Inspectors compare the breaker rating to the grounding conductor gauge. If it does not match the table, it fails. Every conductor inside a box takes up space. Pack too many wires into a box that is too small, and you are looking at damaged insulation and overheating. The rule is NEC 314.16. Inspectors count conductors and compare them to the cubic inch volume stamped inside the box. If the math does not work, the box gets rejected. For EMT, NEC 358.30 is the rule. Support required within 3 feet of each outlet box, junction box, device box, cabinet, conduit body, or other termination point, and at intervals not exceeding 10 feet along the run. Unsupported conduit puts stress on fittings and fails inspections. Inspectors look for missing straps near boxes and long unsupported horizontal runs. Breakers protect conductors. NEC 240.4d sets hard limits for small conductors. 14 AWG copper, 15 amp maximum. 12 AWG copper, 20 amp maximum. 10 AWG copper, 30 amp maximum. These are hard ceilings, not suggestions. 240.4d controls the overcurrent protection for all three conductor sizes, regardless of what Table 310.16 shows for ampacity. Always confirm the equipment terminal rating matches. Inspectors check conductor gauge against breaker size inside every panel. NEC 300.4 requires physical protection for cables near framing edges. If a cable runs within 1 1/4 inches of the edge of a framing member, a steel nail plate at least 1/16 inch thick is required. This applies to stud penetrations and parallel runs near framing. Inspectors check every stud penetration. Missing nail plates fail inspections consistently. Multiwire branch circuits share a neutral. NEC 210.4b requires a common disconnecting means, typically a 2-pole breaker or a handle tie. The two hot conductors must land on opposite phases. Same phase means the neutral carries combined current. That overheats the conductor and creates a fire hazard. Inspectors check for shared neutrals without handle ties in every panel. Exam tip: multi-wire branch circuit rules appear consistently on the Florida EC exam under the branch circuit design domain. GFCI protection detects an imbalance of approximately 5 milliamps between hot and neutral and shuts off power in milliseconds. NEC 210.8 covers the required locations. The list includes bathrooms, kitchens, garages, outdoors, crawl spaces, unfinished basements, laundry areas, and receptacles within 6 feet of any sink, among other locations. Check 210.8 for the complete list, because the 2023 NEC expanded it significantly. NEC 422.5 adds dishwashers to the GFCI requirement. Exam tip: know the full 210.8 location list. It is one of the most tested sections on the Florida EC exam under the GFCI and AFCI protection domain. The grounding electrode conductor connects the electrical system to earth. It stabilizes voltage and handles lightning surges. Do not confuse this with the equipment grounding conductor. That is the one inside the conduit that clears faults. The grounding electrode conductor goes from the panel to the earth. Size it using Table 250.66. One exception many electricians miss. NEC 250.66a says when the grounding electrode conductor connects only to a rod, pipe, or plate electrode, it is not required to be larger than 6 AWG copper. That exception shows up on the Florida EC exam regularly under the grounding and bonding domain. Inspectors verify sizing at the service equipment and at the electrode connection. 10 mistakes. 10 rules that fail inspections and show up on licensing exams. Overfilled conduit. Wrong ampacity column. Undersized grounding conductors. Box fill violations. Unsupported conduit. Wrong breaker size. Missing nail plates. Multi-wire circuit errors. Missing GFCI protection. Incorrect grounding electrode sizing. Know these cold, and you will pass more inspections and more exam questions. If this breakdown was useful, subscribe for more NEC content every Tuesday and Thursday.